Formulas arise frequently in the natural and social sciences, business, engineering, and healthcare. We often need to solve such a formula for a variable. We're going to take a look at some examples of solving formulas, and you'll see that we use the same steps that we use to solve equations. Probably the greatest difference is that whereas the solution of an equation is a number, the solution of a formula is generally a variable expression. And here's our first example. They're giving us this formula and asking us to solve for g. To solve for g, we're going to eliminate the rational expression by multiplying each and every term by the least common denominator, which is 2, given it's the only denominator. So multiplying both sides by 2, and keeping in mind that we want to solve for g, we end up with 2s is equal to, since these are additive inverses, 1 times gt squared. Now the only thing that's happening to g is a multiplication by t squared, so we'll divide both sides by t squared, giving us the final solution of g equal to the quantity 2s over t squared. Here we have a formula from the business world. This is an interest formula. And to solve this, we're looking to get the variable t by itself. To do that, we're going to peel away the layers, and the first thing will be to divide both sides by p. That will leave us with the quantity in the parentheses. Next, to get t by itself, we need to eliminate the 1, so we'll subtract 1 from both sides. Because we don't have like terms, we have to use and don't know values for a or p. We have to leave that rational expression a over p and simply subtract 1. Last, we need to eliminate the coefficient on t so that we only have a coefficient of 1. So dividing both sides by r results in the following equation. We also could have multiplied by 1 over r, the reciprocal of r, and ended up with an equivalent answer for the value of t. Here we have another equation, which is a radical equation, and we are asked to solve for h. We want to isolate the radical first, so we'll divide both sides by c, canceling out c on the right. Because of the variables and not knowing values, we have to leave the left side as d over c. Next, to get h by itself, to undo a square root, we will raise both sides to the second power. Squaring a radical gives us the radicand, and squaring a quotient will square each of the numerator and the denominator terms. So here we have the solution for h. Here's an application from the geometry world, and the directions are to solve for h. Similar to the last problem, we need to eliminate the coefficient of this quantity in the parentheses. To accomplish that, we'll divide both sides by 2 pi r. And because of the fact that we don't know values of these variables, we'll just leave it as s over the quantity 2 pi r. To solve for h, we need to undo the addition of an r. The opposite of addition is subtraction. Subtracting an r from each side results in the following solution for the value of h. In this last equation, we have a formula that is a rational equation, and the directions are to solve for n. It is a rational equation, however, and to eliminate a rational equation, we multiply by the least common multiple or denominator, which in this case will be n. Dividing both sides by n cancels out the rational expression on the left and puts our variable on the right side. To undo multiplication that's occurring on the variable n, we'll divide both sides by r, giving us a solution of n equal to m over r.